Hi guys, my name is Chrissy Gastides, and today I'm going to be talking to you guys about the impact of microplastics on seabird health. Plastic pollution is a problem that has been progressively getting worse since the 1950s. Plastic production has just been increasing. We use plastic in almost everything. Yearly, over 14 million tons of plastic enter the ocean. Plastics can exist either as macro plastics, such as fishing gears, water bottles, and plastic straws that we see here in this picture. Or plastics can exist as microplastics, which are classified as smaller than 5 millimeters. Now, microplastics can then be further broken down into primary and secondary microplastics. Now, primary microplastics are manufactured microplastics, such as in facial washes and things like that, while secondary microplastics originate from the breakdown of plastics over time, such as a water bottle degrading over time. Now, why does this matter? Well, this matters because plastic pollution affects more than just marine ecosystems. Plastic pollution can affect organisms such as humans like ourselves and other ecosystems as well. Microplastics can enter the food chain by being consumed by plankton, which then are eaten by smaller fish and then bigger fish and then ultimately seabirds. Now, essentially, this means that seabirds are ingesting microplastics both directly and indirectly through their prey. Seabirds are considered bioindicators of marine ecosystem health. They're considered bioindicators because they forage over such vast and large areas and they feed at multiple trophic levels. Now, microplastics in seabirds basically reflect a widespread contamination of the marine food web. Monitoring seabirds and their health can help provide some insight of the marine ecosystem, helping scientists assess the severity of plastic pollution, track long-term environmental changes, and evaluate the effectiveness of plastic conservation efforts. Seabirds are highly vulnerable to microplastic pollution due to their foraging behaviors. So, this study aims to determine how microplastic pollution affects seabird health, specifically how it affects their digestive efficiency and hormonal balance. Microplastic ingestion can cause gut blockages and microbial imbalances, reducing nutrient absorption. Endocrine disrupting chemicals in microplastics can also interfere with hormonal regulation, affecting metabolism and reproduction. As previously mentioned, seabirds can ingest microplastic directly and indirectly. In the top image that you see here, pieces of plastic that were taken out of a bird's digestive system. When we think of seabirds and plastic, we tend to think of seabirds being entangled with fishing lines or seabirds swallowing some sort of plastic and suffocating. However, these are only some of the physical impairments effects of plastic. Plastic ingestion can also lead to gut ulcers, obstruction, and perforation. Now, in this study, we did notice that there are foraging behavior and color preferences noted in seabirds. Now, coastal foraging seabirds, which feed near shorelines, tend to have a higher rate of plastic ingestion compared to pelagic seabirds, which are seabirds that basically feed in the open ocean. Along with there being differences in the type of seabirds digesting plastic more frequently, there's also differences in the colors of plastic being ingested. Certain colors are ingested more frequently. Transparent colors tend to be ingested more frequently first, and then black, and then blue. Now, on the graph that you see down here from Diaz-Domingo study, on the left side, specifically A and C, you could see the common colors of plastic found in seabirds' GI tract, while the right in B and D shows common colors in regurgitated prey. Certain colors can be preferred more due to visual foraging cues that seabirds get when they're hunting down their prey and just environmental availability. When seabirds ingest microplastics, there are various physical effects. Plastic tends to accumulate in the stomach and intestines, which then causes an obstruction. Obstructions cause false satiety, meaning that the birds feel full and will eat less. This leads to malnutrition. Blockages can also reduce nutrient absorption. Internal damage occurs when sharp plastic fragments such as ulcers and inflammation and perforation of the stomach. This weakens the stomach's ability to digest food and extract nutrients. These effects can reduce the bird's energy intake, which can affect the survival rate of the birds. The image on the top shows a grading scheme that demonstrates how prolonged plastic exposure thickens and disorganizes stomach tissue. Grade 0 is a healthy tissue, and then it shows progressive thickening and loss of tubular gland structure as we move from grade 1 all the way to grade 5. Now, the image on the bottom then shows plastic ingestion can cause swelling, irregular shapes, and loss of digestive gland function. This reduces enzyme secretion and nutrient absorption as well. Now, over time, all these structural changes weaken digestive efficiency of the seabird. Seabirds rely on a balanced gut microbiome for digestion, immunity, and nutrient absorption. However, microplastic ingestion disrupts this microbial balance, which can lead to digestive inefficiencies and health issues. The graph here demonstrates the correlation between microplastic ingestion and changes in microbiome diversity. Now, alpha diversity metrics show how microbial richness changes with increasing microplastic exposure. The proventriculus, which you see here has blue dots, is essentially the stomach in a seabird. And the cloacal orange dots that you see here basically are the intestines of the seabird. Now, the blue dots and the orange dots respond differently to microplastic ingestion, indicating localized microbiome disruption in different sections of the digestive tract. There are stronger changes in the stomach, which is the proventriculus, compared to the intestinal cloacal changes. The graph essentially shows that as seabirds ingest more plastic pieces, microbial diversity increases because new microbes are introduced. However, when the total mass of plastic increases, microbial diversity decreases. Basically, some levels of microplastic ingestion introduces some microbes, but too much plastic ingestion disrupts microbial balance. Now, I wanted to bring back attention to this chart seen earlier. Chemicals in plastic can cause a variety of toxicological effects. Many plastic contain endocrine disrupting chemicals, which include bisphenol A, also known as BPA, phthalates, and perfluoroalkyl substances, also known as PFAS. These chemicals can mimic or block natural hormones, particularly those involved in thyroid function and reproduction. Disrupting these pathways can lead to metabolic issues and weaken immune responses, making seabirds more vulnerable to environmental stressors. Microplastic exposure in seabirds have been linked to changes in blood chemistry, affecting hormone levels, lipid metabolism, and stress markers of seabirds. Elevated cholesterol levels are linked to plastic ingestion and are potentially due to the chemical exposure and stress. The reduced calcium levels in the blood chemistry of seabirds are due to increased chemical exposure and poor fat reserves due to the malnutrition that the seabirds go through with the plastic ingestion. Increased uric acid levels in the blood chemistry indicate either metabolic disruptions and renal stress. Seabirds that feed near human populations, such as the coastal foraging seabirds I mentioned earlier, accumulate more endocrine disrupting chemicals due to having higher concentrations of microplastics in them and higher contamination levels. As previously mentioned, seabirds serve as bioindicators. Since seabirds serve as bioindicators, their high plastic ingestion reflects marine ecosystem health. This emphasizes the need for pollution control and habitat protection. Reducing plastic waste and improving marine policies can help mitigate plastic exposure, protecting seabirds. While the current research lets us know that microplastics are affecting our marine ecosystem, more research is needed to understand long-term health effects and how microplastics are affecting other ecosystems as well. Using blood and tissue markers can help track plastic exposure and improve conservation strategies. Okay, this is page 1 of my references. This is page 2 of my references. Thank you so much for joining me on this talk today. Any questions?